Hello, good evening everyone. Am I audible? Yeah, good evening. So, what were we discussing in the last class, everyone? What were we discussing in the last class? Yeah, so here what I have done is okay, I have uploaded the template. So, last time we were creating the project template, right? We created .ccp files, .h files. We try to define few macros and also few prototypes. So that everything I have put it here. Okay, can you please download it from here, and whatever I'm doing today, that you can implement after watching the recorded session. If possible, you can do along. Okay. Yeah, so can you tell me what we'll be discussing in the last class, everyone? What we'll be discussing in the last class? Yeah, we were discussing about how to write a code for what node 1. How to write a code for what node 1. So yes, that part only we will continue today. We could not complete in the last class. So in the last class, okay, till what I have completed is sensor begin. What we did was we have created this node 1. Okay, as we discussed, here is our discussion. What we did last time is like from production line, we are supposed to push the data to ThingsBoard. That part we are implementing here. What is that? Connect the sensor to the node 1 and push that data to the okay cloud. That is ThingsBoard. Okay. So here what I have done is I have created separate files for that. Okay. Node 1, not INO, node 1. Okay. We have created these files. Okay. Where I am going to put sensors part here, network part here, and the telemetry, whatever we are going to transmit. Okay. Then config.h. Like this we have done. And we know this is our steps here to initialize the sensors, actuators, connect the board to the internet and MQTT, then read the data from the sensors and then publish it to the cloud. These are our steps, and according to that steps only we have created this template. If you have created template, good. If you have not created, already I have uploaded it in the LMS. Already I have uploaded this template in the LMS. Please go and fetch it from there. Please go and fetch it from there. Okay. So here I have included the file spi.h, Ethernet. These all things we have done. We'll proceed further. Okay, sensors.begin we have created here in the sensor manager.ccp. What I have created is okay. I have initialized the DHT. Okay, here I have made a switch. Okay, one switch is there that as a input. This is what we have done, and DHT begin. This is what we have done now. Correct? Okay, fine. Then in the sensor manager.h, okay, what we have done is we have included few functions here. Sensor.begin, okay, sensor read and sensor free memory. I will explain them. Okay, coming back here, we are done with initialization of the sensor. Next, we'll initialize the actuators. Okay, we'll initialize what? actuators. Okay. So in the actuators dot begin, what all we are having here as a part of actuators? 1 minute. I'll open the requirement document as well. I'll open the requirement document as well. Yeah, from the requirement document here for node 1, I'll open it. Yeah, so if you see the node 1 here, we have sensors LM35, okay, DHT22, all these are sensors. Vibration is again sensor. One actuator, what we have is actually relay. Okay, we should control one relay. Okay, that we are supposed to initialize. And few LEDs. Relay, as I told, we will be handling it in the RPC. Okay, that we'll see later. As of now, we'll just okay initialize this okay yellow, green, and okay, red LEDs to indicate the errors. Only this much we will initialize here for now. Okay, so going back to the actuators, we have to just configure those pins as what? Okay, output pin. Okay, so actuator.h. In the actuator.h, what I am doing is I have included the Arduino.h and config.h. These actuator functions, we'll see them later. Okay, as of now, this is only function where we are going to initialize the actuators. So I'll just copy it. Okay, so here I'm including okay actuator.h file. Okay, so what I'm going to do here is to begin the actuators. We have to initialize them. We have to initialize them. So do you remember what are these LEDs are used for? I have to configure these LEDs are output pin. Okay, can you tell me? The file I provided doesn't contain CPP. It is having CPP. Magdum, it is having .cpp and other file. Are you sure? It is a zip file. You have to unzip it. It is a zip file. This project template is a zip file. You unzip it. It is having all the files. Anyone downloaded it? Sai Akshita, did you download it? Config.cpp we don't have. We are not using that. We don't have config.cpp. We are having only .h. There only macros we are defining, no functions. Only it is .h only we are using. No .cpp. We will not have any function definitions. So no .cpp. Yeah, good Sangeeta. It's fine. If you have done it yourself is also fine. But I have added few more things which you don't have. So better you download it. Okay, Sangeeta. Download the template. Everyone download the template which I am giving because few more things I have added there. Okay, few more macros and function prototypes I have added them. Please download them. Yeah, download the template I have provided and use that one only. So here actuators we are going to begin. That is nothing but three LEDs. Okay, what is the use of these three LEDs? I'm using red LED, green LED and yellow LED. So what are they meant for? Why we are using them in our project? The green LED download, okay. Green LED, okay. Then red LED and the other things. Why are we using them in our project? Green, red and yellow LED. What is the use of these LEDs? Yeah. So why we are using this LEDs means red LED, we are green LED is to indicate that connection is normal. Okay, red LED if the connection is not connected, it's not getting connected, and yellow LED is for warning. Okay. So that purpose we are using the LEDs here. So we have to configure them. Okay, those pins, wherever we are connecting those LEDs, we have to configure those pins. Can you tell me what I have to configure those pins as input or output? Those pins, should I connect them as input or output? Yeah, we have to, what we have to do is we have to, okay, make these pins as what? Output. We have to configure these pins as what? Output. Yeah, pin red LED, LED red, LED green and LED yellow, these all pins I have to configure them as what? Output. Okay, so pin mode, I have to configure them as output by using this function called pin mode. Pin mode, okay, whatever the pins are there, I have to take that pins and configure them as what? Output. Okay, I will just copy this. Yeah, green, yellow, okay, then red. Okay, we are configuring the green LED, yellow LED, and red LED as output. Okay, that much only I wanted to initialize here. Okay, we have relays also. As I told, relay is part of what? RPC. So when I'm using RPC, we will take it. Okay, we'll consider it and we will do it. Okay. Okay, are you clear with this? Yeah. So we'll proceed further. So here we are just okay initializing what sensor. Later we are initializing what actuators. Okay. In the beginning, let us keep the actuator here. Okay. Let us keep the red LED high. Why? Because in the beginning, still we have not made any connection. So let it be indicating that still not get connected. Once connected, what we will do is we will update it as what? Okay, green. So initially we'll keep this LED high. Okay. The red LED only on because still we have not okay not getting connected. In the beginning, let it be red only. So red LED, I'll keep it as what high. I'll turn on the red LED. Once internet gets connected, we'll make this as what okay off. We'll make this as what off. For now, we'll keep it on. Okay. So I'll just put here high. Okay. I'll just add comment what in the beginning. In the beginning, okay. Still internet get connected. Till okay, it's getting in a okay board is connected to internet. Till network connection. Okay. LED be on. Okay, red LED be on. Okay, done till here. So here what we are doing, okay, here we have done, okay, sensors begin, actuators begin. See, you are not able to do it along with me, don't do, you just watch it, you can do it later also. So sensor begin, we have done, actuators begin, we have done. Okay, yeah, what is the next step? We have initialized the sensor, we have initialized the, okay, we have initialized the sensor, we have initialized the actuators. Here just to confirm what I will do here, we are booting up the okay on the serial print on the serial monitor. Let us print that we are booting up node 1. We are booting up node 1. Serial dot print node 1 is booting. Node 1 is booting. So I am booting up the node 1. That we will just print it. Done? Yes. Next, what is the next thing we have to do? What is the next thing we have to do now? Yeah, we have to connect our board to what? Okay, internet. We have to connect. We are done with initializing the actuators. We are done with initializing the sensors. Next is what we have to do is we have to connect the board to the internet. So how to connect our board to the internet? How to connect our board to the internet? Okay, for that we have libraries here, Ethernet library and PubSub client library. So first we have to create a objects of this type. After that we have to get it connected to the internet. So for that, what I'm going to do is I'm going to use a separate function called network begin. I'm going to use a separate function called what? Network begin. Okay, network begin. Okay. So let us create here objects of type Ethernet. I will just add comment, create object of type Ethernet and PubSub client. PubSub client. See, I'll be not waiting for anyone to type it along with me. Okay, so what you have to do is you have to watch the recorded session and you have to implement. Fine. About libraries, already we have installed the libraries, same libraries we are using. No need to install anything new. Okay, these all libraries we have used them previously in our when we are writing the sample codes. So I'm going to create here library. Okay, so sorry, I'm going to create here objects of Ethernet. Okay, so I'm going to take it as static. Ethernet. Okay, client. Okay, and I'm going to create here Ethernet client object. Ethernet client object. Then static. Okay, pub sub client I'm going to create. Pub sub client. Okay, here I'm going to create a object MQTT client. MQTT client. MQTT client. And I'll be passing here Ethernet client. I'll be passing here what? Ethernet client. Ethernet client. Yeah, static Ethernet client. Here, what I'm doing, I'm created two objects. I have created object like Ethernet client, and we have created object MQTT client. Yeah, done. So here we have created two objects. Now we will use them, and we will okay. Yeah, so here I'm going to create a function called network begin. So here in the network we are having network.h. So the network.h here we are having the one function. You can see I have already created one file network.h. In the network.h we are having Arduino.h, Ethernet.h, pubsub client.h, config.h. Here few function prototypes are there. We will see them one by one. As of now, I'll just explain you about network begin. In the network begin, what we will be doing means we'll pass this, okay, MQTT client object and on connect. See, when it get connected to internet, what you want to do first? That function we are passing here. Okay, that function we will be passing here. As of now, I don't have any intention to pass any function. So let us not do anything here. Okay, we will see later. Now I will not do anything on connected. Yeah, I'll just pass here MQTT object, and this object we will just connect it to the cloud. That much only we will do. I don't want to do on connect. I don't want to do anything here. Fine. Okay. So if required, we'll see that later. Yeah. So I'll just call this function here. I'll copy network.begin in the main. Yeah. And we will be passing here that MQTT object. What is our MQTT object? Is MQTT client. This I'll pass here. This I'll be passing to this function. I'll be passing this to a function. Getting my point? What I'm doing, I created object MQTT client here. I'm passing here. So this is nothing but I'm going to connect board to the internet. I'm going to connect the board to the internet. Okay, I'll pass here base address. I'm connecting this as a pointer. Yeah, base address ampersand MQTT client. Yeah, so here I'll try to define this function. I'm copying this. I am going to define this. See, whatever in the header files, whatever functions are there, right? We are going to add the definitions in the .cpp files. We are going to add that, okay, definitions in the .cpp file. Okay, so hash include. Okay, so what I'm doing here is I'm adding here the network.h, okay, header file. Yeah, so what I'm doing here is I'm going to define this function. I'm going to add this function here. Yeah. So what we are planning to do here, network begin, we have to connect this to the our board. So to connect to the board, what we are having is board, okay, broker address we are having. Using that, we will connect it to the board. Yeah, we'll create here a few, okay, things and we'll assign the values. Static is a keyword, so only it is colorful. Static is a keyword, so it is colorful. What you mean by static means static, it is only, okay, used in that particular file. You cannot use that variable in the other files. You cannot use that variable in the other files. Okay. So whatever, okay, I will create here a few more objects here. Pub client. MQTT. Okay, I'm just initializing it to null. Okay. Yeah. So here what I'm doing, I'm just initializing that. Whatever object I'm passing, I'm assigning it to the variable here, the local variable, okay, MQTT. For local variable MQTT, I'm assigning it. Yeah. Now what I have to do is I will pass here. Okay, I need here MAC address also to connect the board. So I'll take here MAC address. Okay, so here I'll be taking MAC. Okay, a MAC address where I'll be assigning here node MAC already. We have .config. Yeah, MAC address I'm going to put here node MAC. I'm storing it into array. Okay, when we are connecting the board, what I need is I need a MAC address here. I need what? MAC address here. So here I have that Ethernet begin function is there. There I'll be passing. Okay. Okay, to connect to the internet. Connect board to the internet. Connect board to the internet. So to connect board to the internet, what I have to do is, okay, I have to pass here what? Ethernet. Ethernet. Okay. Dot begin, and here I have to pass, okay, the MAC address. I have to pass here what? The MAC address to connect the board to the internet. Okay, here I'm passing the MAC address. Okay, this is done. We'll provide certain delay here. I'll provide delay of 2 seconds or 5 seconds is, or 2 seconds is enough. Okay, 2000. This is nothing but delay to, okay, get it connected to the internet. Sometime we will give it. Yeah. Next is what? We have to connect this to the ThingsBoard. Connecting to internet. Next is connect to the ThingsBoard. To connect to the ThingsBoard, what we need? We need what? Okay, MQTT address. We need what? MQTT address. Yeah, where we are having that MQTT address, that all things I have put here in the config.h already. Yeah, this is my server. Okay, ThingsBoard server address, ThingsBoard port, and ThingsBoard authentication token, and the client ID. Using these things, what I have to do is I should get connected my, okay, board to the ThingsBoard. Okay, we'll go back here. First, I will just, we have that function set server. We will use that and we will create it. Okay, here I have that MQTT object. MQTT. Okay, we are using here what? The pointer. Okay, we are using here the pointer. We are going to use it here. Set server. Set server. We have created our object, right, using this. Okay, what we are going to do, so you can use dot or you can use arrow operator, both are same. You can see here ethernet dot begin or ethernet arrow set server, both are same. Okay, both are same. So here what I'm doing here is MQTT. Okay, arrow, I'm going to use this to connect to the ThingsBoard. This is the object of type what? MQTT is nothing but type. Okay, it's object of type pub sub client. You can use MQTT dot set server, which we have used previously, like this also, or you can use it like this also. Anything is fine, same thing. Okay, MQTT set server, we will have to pass here the ThingsBoard server address. ThingsBoard. Okay, server address, and we have to pass the ThingsBoard port number. ThingsBoard port number. Then, okay, after that do connect function we will call do connect. Means if not getting connected, we have to, okay, we have to connect it to the ThingsBoard. Do connect. We are calling that function here, do connect. Now we will define that do connect function. Do connect is nothing but we'll pass the client ID, access token and everything, and we'll connect it to the, okay, ThingsBoard. So here I have already defined that function, means prototype is there. No, prototype is not there here. Do connect. Let us define this. Okay, this function static, because I'm not going to call it in any other function. Static void do connect. Yeah. So what we are going to do here is we are trying to connect it to the, okay, ThingsBoard. So here what I will do, we'll check, okay, if it's connected or not. If not connected, we'll try to reconnect. Okay, we'll also print the message it did not get connected. Okay, so here I'm having, I'll use this if I'm going to check that. See, this is there in our sample code. Okay, it's not that anything new. In the I'll just open you the sample code so that you can relate it here. In the classwork, we have done this. I'm just showing you, you need not open this. I'm just trying to show you, relate it, like which we have done previously. Yeah, this is my code now. This is my what code. Okay, last time what we did, we checked here if client got connected, if not reconnect. In the reconnect function, what we did, we passed this access token and we try to connect it again. Okay, access token, the name, okay, and try to reconnect. If not getting connected, we are trying to reconnect. That's what we are doing here. Client is connected, if not reconnect. Same thing here. What we will do, we'll also check here also. We'll check if it's getting connected to the ThingsBoard because we have sent a request. If not getting connected, we'll try to reconnect. So I'm checking here MQTT MQTT. Okay, you can use arrow also, you can use here dot also, anything. If MQTT connect, okay, is it true or not? I have to pass here what? Okay, the client ID means your client ID is nothing but your what name you want to give to this board. I'm giving production line node 1. See, you try to give some unique names. I am putting 001, you put one more zero, or try to change something. Okay, change something here. Don't keep the names same. Okay, keep the name unique. Don't copy as what I have taken. You change it. Okay, so I'll take here client ID. Yeah, in the network.cpp. Okay, client ID, comma, means you have to tell your count. Okay, I'm just adding the comment here. Connecting to ThingsBoard. Connecting to ThingsBoard. Yes, you need access token. You already have, right? You have access token. You don't have access token. I whatever okay code I have given to you, there my access token is there. You please don't copy that one. Okay, this is the access token which it's my device access token. Okay, I last time only I told you what you have to paste it here. You already have your device created, production line we have created. Remember that access token you put here. That access token you put it here. Getting my point? Yeah. So I'm going back here. In the network.cpp, I am passing here what client ID, access token, access token, and null. I'm not passing anything here. Yeah. So you put your access token, whatever access token you are having, that one you put it here. Yeah. So what I'm trying to do here is I'm trying to connect it to ThingsBoard. If this is not getting connected, if not connected, we'll try to reattempt here. If it's getting connected, we will okay, just keep it as it is. If and else part. Yeah. So here we will be just keeping it empty. If want, we will okay try to print anything. As of now, I'll just keep it empty if it is getting connected. Okay, here we have to add few more things that we'll see later. For now, I'm just keeping it empty. Yeah. So if it's not getting connected, I'll just print it. Okay, not connected, and I'll try to reattempt. I will try to reattempt. Okay, I'll just print here, not getting connected. For now, I'll just print here serial dot print connected else failed. I'm just printing here, it's connected. failed. MQTT failed. MQTT failed. Okay, fine. Is this clear? This what we are doing here is that just we are getting it connected. Yeah. Upon connection, what we have to do now? You have to turn off the okay LED. We have to turn off the what? Red LED. Upon connection, what we have to do is we have to turn off the red LED. Going back to the main Uno. Here what I will do, I'll just turn off the red LED. Okay. Okay, digital write. Digital write. Pin. LED. Red. Low. Okay, that's what we are trying to do here. Next, what we will do here is okay. Now what we have to do? Now we are done with what? Okay, sensors begin. We have done actuator begin. We have done. Okay, network begin means connected to the board. Next is read the data from the sensor and push it to the cloud. But before doing that, we have to maintain the network. Means we have to keep checking whether the board is connected to the cloud or not. If not, we have to keep reconnecting it. Okay, we have to keep looping there. So in order to keep looping there, I'll take a separate function. Okay, what I have to do is okay, keep checking the network connection. Keep checking the network connection. We have to keep checking that whether board is connected to the things board or not. If not, I have to reattempt. So that I will take a separate function. Keep checking if board connected to things board. If board is okay connected to things board. Things board. Okay. If not, I have to reconnect. Okay. So I have putting it here. Okay. So I will take a function called network maintain for that one. Network maintain. See, these all things we will take certain time here, but note 2 you will not take so much time because already we have these things ready for note 2. Okay, we can go ahead. Okay, directly. That time I'll not be explaining these all functions. Okay. So network maintain. In the network maintain, what I will do here is I'll take a separate. We have taken a separate function called network maintain. I'll copy paste this. We will define it here. Why it's not coming? Yeah, network maintain. In the network maintain, what I will be doing means I'll be keeping okay board connected to the things board. In place of null, should we keep access token? No. Access token we are passing here already. Client ID, access token, then null. You can see what we did last time as well. Okay, last time what we passed? Node, token, null. Same thing. Node, token, and null. Null is nothing but what if you are using any password, anything, we are going to pass it. For now, we are not putting any password or anything. Okay. You can see here, you can see about this method connect. In that, we have to pass the ID. Okay, then the access token, then the password. If you want, you can pass here your password. You can set a password. But I'm not using any password. I'm just keeping it open. So only null. So only null. Is this clear, Lakshmi? No null, just pass access token. Is it clear, Harish Kumar? Access token is here only. We are passing it here, no first place. Okay, first place only we are passing the token. First place pass the token, client ID, then null. Yeah, network maintain. So what we are trying to do in the network maintain, we are keeping checking that whether board is connected to in network or not. If not, we have to reattempt the connections. Yeah, so we will be calling your function Ethernet maintain. This is a built-in function of the Ethernet library. Ethernet. Okay. So yeah, Ethernet. What we are doing is we are trying to connect. Then again we'll check if the MQTT connected or not. If not, if connected, we have to keep looping here. If not, I have to try to reattempt again. So as per the requirement, after how much time I have to reattempt the connection? As per the requirement, after how much time we have to reattempt for the connection? Okay. Okay. So for that here, reconnect interval 5 seconds. So I will try to reconnect every 5 seconds. If not connected, I'll try to reconnect every 5 seconds here. Okay, so in the network.cpp, what we will do is we'll check if a MQTT is connected. Okay, I'll comment here. What we are doing, we are continuously checking if board connected to things board. If not, okay, if not, what I have to do is I have to try to reconnect. Try to reconnect after every 5 seconds, not again continuously. Try to reconnect after 5 seconds or every 5 seconds. Every 5 seconds. So here I'll be using the function again, same if MQTT dot connected. Okay, if MQTT dot connected. Okay, then what we have here, MQTT loop. Yeah, so what we are doing here, we are checking if MQTT got connected. If not, we are trying to reconnect. So we are having here, okay, after 5 seconds, I have to try to reconnect again. If connected, we keep looping here. If not, what we are doing is we are try to reconnect. For that, what I will do is I will use that millis function. I will use the millis function. Okay. Okay. I will take here one variable and sign long static. A variable I need to store the last count. Okay, long. The millis will give us long, okay, unsigned long data. Okay, last, reconnect. Okay, reconnect time, I'm initializing it to 0. I'm initializing it to what? 0. Yeah. So here what I will do here is I will check if it is not, it's for 5 seconds. If it is 5 seconds, I will, okay, try to reconnect. Unsigned long, millis. I'll take a variable now equal to millis. Millis just tell us what? How much time has been elapsed. Already we have seen the usage of this millis, okay, function. Okay, so what I'm doing here is I'm taking now, okay, minus, okay, I'm checking the last, okay, reconnect time. Okay, last reconnect time is now initially 0. Okay, I'll check whether it's 5 seconds. I'll just copy this variable. I'm checking whether it's greater than 5 seconds. I'll check whether it's greater than 5 seconds. So for that already we have macro. What is the macro for 5 seconds we have taken? The reconnect interval. Okay, the reconnect interval is here. I'm just copying it. Okay, so I'm checking here if it is greater than 5 seconds. Okay, time elapsed. This is nothing but delay I'm providing here. Okay, we have seen this already, how to use this millis function. So if it is greater than 5 seconds, I'll try to reconnect. Okay, so before that, last reconnect time, I will just assign it to the now. Okay, and here we will do connect. We will call the function do connect. We'll call the function here what? Do connect. We'll call the function do connect. Fine. Is this clear? Yeah. So what we are doing here in the network maintain, I am just checking if the MQTT is connected. If connected, we are calling this loop function. If not, we are trying to reattempt for the connection. Reattempt for the connection. This is what we are doing here. That to every 5 seconds. That to every 5 seconds. Done. Then going back to the main now. Now what happened? Our network got connected. The network got connected. Next thing is to read the data from the sensors. Read the data from what? Sensors. So what all sensors we are planning to use here in this project? What all sensors we are planning to use for node 1? If you refer the document here. If you refer the document, what all sensor we are planning to use here? Yeah, we are planning to use what? Okay, DHT22, LM35 and vibration sensor. So we need vibration data, temperature data, humidity data. And also we have to check if there is error in the sensor. So we need different variables here. So for that all variables together, I'm going to use here one structure. I'm going to use here something called structure. So here I have created a structure. Structure is nothing but, okay, it's a one data type. It's a one user defined data type. So this structure is having, okay, float. Okay, I'm creating float temperature, float humidity, float LM35 temperature, vibration, machine status, whether machine is on or off, and also, okay, the sensor error. Okay, this is my structure sensor data. So using this, I can copy any object. I can read any object. Okay. So whatever things I'm planning to read, I'm all creating them as variables. I'm creating them all as what? Variables using structures. Yeah, the structures will actually help us to reduce the, okay, optimize the, okay, our memory. Okay, I'll be not telling more about structures here. Okay, you need to study it because it is completely C. Okay, I'm just using structures here. Okay, we are not, okay, and this internship is not about teaching advanced level C. We are just using a C and we are trying to implement this project. Okay, so here what I'm doing is I'm creating the structure, okay, of day of structure name is sensor data, and these are the objects of that structure. Okay, so sensor begin already we have done. Now we are going to implement this sensor read. So where I'm going to read the data, I'll copy this, control C. Okay, next our task is what? To read the data from the sensor. To read the data from the sensor. So that what I'm trying to do here. Okay, read data from the sensors. Okay, and also what this function will do means it will return the status of the sensor. Return status of DHT22. Okay, if it is an error, it will return what? 0. If there is any error, okay, it will return 0. Returns 0 on error. Returns 0 on error. I have to comment this. I'll comment it. It's not any function. It's not any code. Just comment it. What this function will do? Read data from the sensors and return the status of DHT22. Returns 0 on error. This is what we are trying to do here now. Yeah, we have to supposed to read now what? Data like humidity, temperature, LM35 and as well as vibration sensor. And also the status of the machine. Okay, so first we will read the humidity and temperature. We already have initialized this DHT library. Okay, we have the library functions known how to read the DHT data. That we will do it now. Yeah, for that I will create a variables to read the sensor data. Static float. I'll do it. Yeah. So first we have to read here. Okay. Yeah. So here what all things I have to read, I'll just add them as a comment. First I have to read DHT, DHT22 sensor. Then after that read vibration sensor, read vibration sensor, then read the LM35. Read LM35. Read LM35. Yeah. So how to read the DHT sensor? We have the already functions ready for that one. So what I will do here is I'll create float float T. To read DHT we are having here DHT dot. We know this. We have the already the functions for the DHT library. Read temperature. Read temperature. Then read humidity. I'll just copy paste this. Yes. Yeah. Read humidity. Instead of temperature, I'll call here function humidity. Humidity. Fine. Okay. Then after that, what we have to check is nan function is there. See if I'll open the sample code. Yeah, so you can see here, this is how we read this humidity and temperature. Here, is nan means what? We are checking if there is error or not. Correct? Same thing we will be using here. So if there is error, yeah, is nan is to check what error? To check if there is any error in the, means if it is not able to read. If it is there is error in the sensor reading. If error in DHT DHT sensor. Okay, if is nan, okay, is nan, okay, and is nan H. Okay, so I'm checking if there is any error in the DHT sensor. If there is any error in the DHT sensor. Okay. If error, what I have to do? I have to signal it. If there is any error, I have to signal it. So here we have created an object, right? For that, we will signal it. Okay, out. Okay, I've created that. Here I'm passing sensor data. This is nothing but a structure. Okay, using that structure, what I will do is in the structure we have this okay variable. What is that variable name? Sensor error. This I have to set it if it is failed. I have to set it if it is failed. So I'll just copy this. This is our okay variable. Okay, I will set it here, indicating that it is failed. Indicating that what it is failed. Then out. Okay. Okay, temperature. Okay. As what I will be doing here means I will copy the last temperature here. For the temperature, I'll copy the what is our last temperature. Reading whatever is there, I'll copy it. If it fails. So for that, what I will do, here we have the requirement. You can see in the requirement it is there. If the sensor fail, we have to cache the previous temperature. If the temperature fails, you can see here. Okay. On DHT22 error, the system shall cache the last valid reading. Means last valid reading, we have to store it and we have to set the sensor error as true. So what I'm doing here is I will take one variables to store the last okay reading. Okay, I will take the variables here to store the last reading. Okay, I'll take it as static float. Okay, last temp and last. Okay, last humidity. Last temp and last humidity. Last humidity. Okay, I'm taking here two variables, last temperature and last humidity. Okay, so whatever the last value is there, we will store it here. Last temperature, then last humidity. Okay, last temperature, last humidity. This is what we are storing here. Whatever the previous value is there. Upon error, we have to store the last value. Okay, this and sensor error, I am setting it as what? 1. Okay. Yes, what is there? Just store the reading. Just store the reading. Else, store the reading. So what we will do here, we have that. Just copy paste them. Okay. So sensor error is 0 here. Okay. So what I will be doing here is I will be rounding. Okay. Round. Okay. So here I am having T. Yeah, so what I'm doing is I'm rounding off this to the okay decimal. So this is nothing but a function that is used to round off it to the decimal. I don't want the float values. I'm just rounding it off to the decimal values. If it is 20.3, I will take it as 20. If it is 23. If it is 25.65, I have to just make it as 25. So that is nothing but we are doing trying to round off the okay float values to the decimal here. Float values to the decimal. So this is the function it is used here. Yeah, this is nothing but temperature. Yeah, so here what we are having is humidity. So we are rounding up the humidity and rounding up the temperature and storing it into this. Okay, what here we are passing this variable, right? Sensor data into this structure. I'm storing them into the structure sensor data. I'm storing them. What we stored here now is first we read the value. We are checking if there is any error. If there is any error, we are signaling it. If not, we are no error means we are not signaling it. Then we are rounding off the values and storing it into a temperature and humidity. Okay, and we will store back into this last also. We have to retain these last values. So I'll just store them back here. Yeah, so I'm storing the last temperature. Then I'll be storing the last humidity. So here we are reading the temperature. Okay, here we are reading the what? Okay, and we are checking whether it is error. This is done. We are done with what? Reading the DHT sensor. If there is an error, what we have to do is we have to store back the last value into the temperature and humidity. This is what we are doing here. Okay, next thing. Okay, next is to read the vibration. So how to read the vibration now? How to read the vibration? What we are planning to do? We don't have vibration sensor. So what was our plan? We don't have any vibration sensor on our board. We don't have any vibration sensor. So we plan to use what? Potentiometer. We plan to use what? Potentiometer. We don't have any vibration sensor on the board. So what we are planning to do is we are planning to okay use the potentiometer instead. Okay, so what I will do here is this is done. Okay, we'll take a separate functions to read the temperature from the LM35 and also read the temperature. Okay, then vibration sensor. Read vibration from potentiometer from pot. Then read okay the LM35 temperature. LM35 temperature. Okay, read vibration and read the temperature. This is what we are planning to do now. Okay, see potentiometer we already know how to read it, nothing but we have analog read function. We use potentiometer for analog read function we have. Then LM35 we have one formula to connect. We have to do again analog read, but we have to convert into temperature. Okay, so for that I will just take function here static unsigned int. Okay, this is a variable type. This is a data type 16-bit T. This is nothing but what? Data type, which means we are returning an unsigned integer of size 16 bits. Of size 16 bits. Okay, read vibration. Read vibration. Okay, read vibration. So here we are going to read the vibration. So to read the vibration, what I will be doing means, okay, I will be okay taking the average four values. I'll be okay taking the average of what? Four values. I'll be just taking the average of what? Four values. Means I will read four values, then divide it by four. Read four values and divide it by four because that is also part of requirement. What is the requirement here? You can see about okay vibration sensor. Yeah, the system shall read average 4 ADC samples on A0 for vibration measurement. So 4 samples we have to read. Means read 4 readings divided by 4. Read 4 readings and divided by 4. So for that also in the config.h, okay, have taken it. Vibration samples. One minute, where is vibration samples? I have not taken it. It's okay. Yeah, vibration. Okay, what we will do, we'll just divide it by 4. Read it by 4 and read 4 samples and divide it by 4. Okay, this last function we will implement. Later I will, okay, disperse. Last. Unsigned int. Okay, 16-bit. Okay, equal to 0. Okay, then I equal to 0. Yeah, then I will be less than 4. Okay, I have to read 4 samples. Okay, I plus plus. I'll be reading here using the for loop. Using what? For loop. I'll be reading the values 4 times. Okay, and add them, then divide by 4. I'll be taking the average of 4. Okay, sum plus sum equal to analog read, and I have to keep adding it here. I have to keep adding it here. Analog read. Yeah, we have that pin vibration from the config.h. I'll copy that A0. Read it from A0. Okay, read it and keep adding to the sum. Read it and keep adding to the sum. Yeah, and we'll provide certain delay here. We'll provide here certain delay. Okay, 1000 we will keep reading it for. Okay, 1000. Okay, 1 second. It's nothing but read it for every 1 second. Then when we keep adding it, read it, add it, read it, add it. Okay, just take it 100 milliseconds for now. I'll just take 100 milliseconds here. Yeah, read it, add it. After reading and adding, what we will do is here return. Okay, sum. Okay, divided by, okay, 4. Sum divided by 4. So what I'm doing, I'm reading the 4 samples, then dividing by 4 means I'm returning the average of 4 samples. I'm returning what? Average of 4 samples. Return average of 4 samples. Clear? So this is to read the vibration. So about temperature, we will see tomorrow. How to read the LM35 temperature sensor, we'll see that tomorrow. Are the things clear till here? What we have done today what we have done is we have connected both to the, okay, MQTT. Okay, first we network begin. We are passing here the client. Okay, and we are connecting to the ThingsBoard. Okay, we are maintaining the network. Then what we have done is we are reading the sensors. We have read the DHT22. Still, okay, vibration sensor is pending, and also the LM35 is pending. If that we finish, we are done with reading. Then tomorrow we will do is we will see how to send the data to the cloud. Tomorrow we'll see how to send the data to the cloud. Fine. Yes. Thank you everyone. You can leave for today. We'll continue tomorrow. I'm telling you, I'll be not sharing this code. Only template will be there. Remaining things you have tomorrow time, right? Watch the session and do it. Or if you have done now only, it's fine. Okay. Thank you everyone. Good night. Homework is implement whatever is done till here. Test will be not, okay, Quiz will be not extended. Okay. Quiz 2 I will extend because you had some festivals, right? Quiz 2 I will extend. Quiz 1 will be not extended. Okay, about quiz 2 let you know later. And everyone, tomorrow you have session. Disha session and resume preparation will be there. Please do attend at 5 o'clock tomorrow. However, I'll put the it in announcement. Tomorrow you have a resume preparation session. Tomorrow you have a resume preparation session at 7 o'clock. Homework is whatever is I have implemented till here, you please implement it, keep it ready for the next session. Okay. Thank you. Good night.